Well, for the whole universe, I'd like to start with an example of imagining that we shrink the entire universe down so that we can fit the entire universe on the United States. So the farthest galaxy, one direction might be in New York City, and in the other direction it might be in Los Angeles. If we could shrink the whole universe down to that size, the Earth would be really, really small. Sometimes people would guess maybe it would be as big as Ada, or maybe as big as a house or a marble or something. But if we could shrink the whole universe down to the size of the United States, the Earth would be so small we couldn't even see it with the most powerful electron microscope that we have. So the universe is just really, really big. One of the things that we could start with to kind of get a feeling for it is just thinking about the solar system itself. So I brought a model with me. Now, one demonstration's worth 1,000 pictures. So I brought this tennis ball, and we're going to pretend that we have shrunk the universe down till the sun is the size of this tennis ball. So this represents the sun. And I wanted to get something to represent the Earth, and I found this pen. And it has a little green, you can maybe see it this way, it has a little green pin head on it. But that pinhead is too big. I measured it, and it's about 5 times as big as the Earth would be compared to the sun. The Earth would be about the size of the metal shaft of the pin itself, less than 1 millimeter across compared to the tennis ball. So the sun is really, really big compared to the Earth. It's about 100 times the diameter of the Earth. Of course, the Earth itself is pretty big. A lot of people don't have much idea how big the Earth is, but it's 8,000 miles in diameter, and it's about 25,000 miles if you go all the way around the equator. So the sun is really big compared to that. And then if you start comparing other stars, a red giant star would typically be 10 to 100 times the diameter of the sun, and a red supergiant star, can't show you that, it would be bigger than this room, probably about the size of a small house compared to the sun here. But to get distances to bigger things, we need to think about the speed of light. Now, light travels 186,000 miles in 1 second. So if you go from the Earth to the Moon and back, light can make that trip in about 3 seconds, from the Earth to the Moon and back. But the sun's a lot farther away than the Moon. So it takes light about 8 minutes to get from the sun to the Earth. And then it takes light 3 or 4 hours to get out to the orbit of Neptune or Pluto. But then to get to the next nearest star, instead of a few hours, it takes 4 years. So the stars are really far away. Let's use our sun again. Let's pretend this tennis ball is a star. The next star, compared to this tennis ball, a lot of people would say, well, it might be out at the airport, or it might be in Oklahoma City. But the nearest star would be another star about the size of this tennis ball out in California, about 1,200 miles away. And in the Milky Way itself, we now know there are about 400 billion stars. Now our sun is just kind of an average star, and there are about 400 billion others, somewhat like it anyway, in the Milky Way galaxy. And we were talking about how fast light travels. We said that it takes light 4 years to go to the next nearest star from the sun. To go all the way across the galaxy, it takes light over 100,000 years. And then if we go to the universe itself, in the late 1920s, it was first proven that the Milky Way isn't all there is to the universe. Astronomers realized that there were lots and lots of fuzzy looking things out there that were shaped like pinwheels or blobs, and that those were galaxies themselves. And at first we thought, well, there are hundreds of galaxies, then we found thousands, and then tens of thousands, and now we're up to the point where with the Hubble Space Telescope we have found that the universe contains almost 100 billion galaxies. Just think about how much that is, 100 billion galaxies, each one with maybe 100 billion stars. So the universe is really, really big, and the more we've learned about it, the bigger we've realized it is. And it's only within the last century that we've been able to fully appreciate how big the universe is. Now, back in Bible times, people thought the Earth was all there was, and the stars were just little lights up there in the sky, and that the planets and the moon and the sun all went around the Earth, and then Copernicus came along with the idea that, hey, maybe the Earth is a planet going around the sun, and that took us down a notch. And then we realized that the Earth is just a planet going around the sun, which goes around the center of the Milky Way, and that took us down another notch. And now we realize that we're just a little tiny planet going around a single star in a pretty normal galaxy that's one out of 100 billion others like it. And that's kind of amazing to me, because you can look at that two ways. Now, some people, when I tell this story to them, they say, wow, that's so depressing. I feel so small because I'm just on this little tiny planet, this little speck in the universe, and there's so much else. And they get kind of sad. But on the other hand, when we look at it from the spiritual point of view, God cares about us, even though we are just on a little tiny speck, floating around the sun, going around the center of the galaxy, and that there are lots of other galaxies. And because God cares about us, that makes us really important. We might be the only intelligent life in the whole universe, as far as we know. We don't have any evidence either way yet, but either way, it's an amazing thing. And that's one of the things that really strikes me about the universe. Now, we just don't know, but what we do know is that God cares about us no matter what.